Hello students, hope you are all doing good. In the previous class we discussed about various quantum numbers. In today's class we shall discuss a new concept called electronic configuration. Right. So topic for today is electronic configuration. Class. The electronic configuration is nothing but the systematic arrangement of electrons in the respective orbits is called electronic configuration. Now, in the yesterday's class, we have discussed that the first shell has only s orbital. This s orbital is called 1s orbital. This s orbital is called 1s orbital because it is there in the first shell. Second shell you have 2s, 2p. The third shell you have 3s, 3p, 3d. The fourth shell you have 4s, 3p, 3d, 4s, 4p, 4d, 4f. This is what you have in the fourth shell. The first shell it is 1s, second shell it is 2s, 2p, third shell it is 3s, 3p, 3d, fourth shell it is 4s, 4p, 4d, 4f. This is how you have the orbitals in the various shells. Now, our next topic is electronic configuration. Electronic configuration is nothing but, as I told you, it's a systematic arrangement of electrons in the respective orbits. Now, you can denote it using a method called NLX method, where n is the principal quantum number, L is the angular momentum quantum number, which represents the subshell, where x denotes the number of electrons. Now, let us see how to use this. If you take hydrogen atom, it has only one electron present in the 1s orbital, 1s subshell. Okay, so you can write electronic configuration of hydrogen as 1s1. Next, if you take helium, it has got two electrons in the s subshell, so you can write the electronic configuration of helium as 1s2. For atoms having more than two electrons, we have to use three principles called Aufbau's principle. First one is Paulie's exclusion principle. Second one is Aufbau's principle. And the third one is Hund's rule. Let us discuss all these three in detail. First one is Paulie's exclusion principle. Paulie's exclusion principle says that no two electrons have all the four quantum numbers same. For example, let us take helium. Helium has got two electrons in the first shell. It has got two electrons in the first shell present in the s subshell. So, let us write the four quantum numbers for both the electrons. First one is n values. Next, first one is n value, second one is L value, third one is ml value, fourth one is ms value. For the first electron, n value is 1. For the second electron also the n value, this is for the first electron and this is for the second electron. N value is 1 because both are there in the first shell. L value is 0 because both are there in the s subshell. ml value is also 0 because there is only one orbital. ms value is if one has plus half, the other will have minus half. If one electron spins in clockwise direction, other electron spins in anti-clockwise direction. This is what is Pauli's exclusion principle. It states that no two electrons have all the four quantum numbers same. That's about Paulie's exclusion principle. Next you have Aufbau's principle. Now you might think that first the electrons fills in the first 1s, then it goes to 2s, 2p, then it goes to 3s, 3p, 3d, 4s, 4p, 4d, 4f. But this is not the order. You have a different order. Let us write the order: 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 2p, 3p, 4p, 5p, 6p, 7p, 3d, 4d, 5d, 6d, 4f, 5f. Now this is the order in which the filling up of electron takes place. First it will go to 1s, next it will go to 2s, next 2p, 3s, next 3p, 4s. It fills in this order but not in this order. So how to see the order is, you have to see for the values of n plus L. Now electron first enters into the orbit having lower n plus L values. This is how the electron fills up. First it will go to 1s, next it will go to 2s, next it will go to 2p, next it will go to 3s. After 3s it will go to 3p, after 3p it will go to 4s, because this has got lesser n plus L value compared to 3d. Let us see what are the n plus L values. Let us compare between 4s and 3d. Here n value is 4, L value for s is 0, so here the value is 4. Here it is 3, L value for D is SPD2, so it is 3 plus 2, which is 5. So among 4s and 3d, 4s has less n plus L value, so that is why electron first goes to 4s, then it goes to 3d, which has more n plus L value compared to 4s. This is how the filling up of electron takes place, and this is called Aufbau's principle. Aufbau's principle states that the filling up of electron takes place in such an order that the electron first enters the orbital having lower n plus L values. Suppose if two orbitals have same n plus L values, then where does the electron go? Suppose if two values have same n plus L values, the electron first enters into the orbital which has less n value. So that is how the filling up of electron takes place, and this is called Aufbau's principle. Next you have something called as Hund's rule. Hund's rule states that, suppose let us take the second shell. In the second shell you have one s orbital and one p orbital, that is 2p. Here let us say the filling up of electrons is like this. Now if I have to add one more electron, I can add it here, or I can add it here, I can add it here. Now where do I add the electron? I should add the electron where the half filling of the orbital is done. That is, I should add the electron here. Once this is done, the next electron starts from here and here and here. So here pairing up of electrons takes place only after the half filling of the degenerate orbitals. Degenerate orbitals means orbitals having same energy are called degenerate orbitals. If you take a particular subshell, the orbitals present in that shell are called degenerate orbitals because they have same energy depending upon the n value. Now, so when the electrons are filled like this, then next electron should come here, the next electron should come here, next electron should come here, and the last must come here. So the filling up of electron takes place only after the half filling of degenerate orbitals. This is what is Hund's rule. Now let us see how to write the electronic configuration of certain elements. We'll write for few elements so that you'll understand for all. Carbon, atomic number is 6. After carbon you have nitrogen, atomic number 7. Then you have oxygen, atomic number 8. Then you have, after oxygen, what is the next element that you have? Fluorine, neon, sodium, aluminium, calcium. Let us say after aluminium you don't have calcium, but let us see how to fill it. Sodium 11, aluminium is 13. Let us see how to write the electronic configuration of these elements. Now, if you take carbon, it has got 6 electrons. Now, the first 2 electrons will be in the first shell. So, 1s2, next electrons goes to 2s, 2s2, next 2 electrons will be there in p subshell, that is 2p2. This is the electronic configuration of carbon. Next for nitrogen, 1s2, 2s2, 2p3. Next for oxygen, 1s2, 2s2, 2p4. Next for fluorine, 1s2, 2s2, 2p5. Next for neon, 1s2, 2s2, 2p6. Now next for sodium, 1s2, 2s2, 2p6. After 2p it goes to 3s. So 1s2, 2s2, 2p6, 3s1. This will give the electronic configuration of sodium. Let's see for aluminium. 1s2, 2s2, 2p6, 3s2. After 3s it will go to 3p. 3s2, 3p1. So this is what is the electronic configuration of aluminium. Next let us look for calcium. 1s2, 2s2, 2p6, 3s2, 3p6. How many electrons are filled? 2, 2, 4 plus 6, 10, 12 plus 6, 18. After 3p where does it go? It goes to 4s. So we can write it as 4s2. So this is what is the electronic configuration of calcium. I hope the topic clear. I want you to check the shapes of s orbital, p orbital, d orbital and d orbitals in your textbook. Just look at the shapes of this orbital. That's an important question. It might come for 2 marks. He might ask you to draw the shapes, or even it might come for 4 marks. So please look into the shapes of the SPD orbitals in the textbook. That's all for today's class, children. We shall continue in the next class.